Everyone, Mr. Aaron's here. Today we were working on 5-7. We're skipping around a little bit, change the order a little bit of these, but we're up to 5-7. We're doing solving equations by adding and subtracting fractions. So we've been adding and subtracting fractions. Now we're going to plug that into our solving equation, something that we already know how to do. Let's dive in here. All right, I made the three little step process here for if you like those, if you like having those steps to follow. First one is get the variable alone. Second one is to find the least common denominator, something we've done before. And the last one is simplify with equivalent fractions. You're going to make those equivalent and solve from there. So let's just jump right in with some examples here. So our goal is to get the variable by itself here. So we have to get rid of this on this side. So what are we going to do? Right now it's a positive 3/10. To undo it, we're going to subtract 3/10. Whatever we do to one side, you already know we have to do to the other. Those cancel out, leaving us with n equals 1/3 minus 3/10. Now, in order to do this subtraction problem easily, this is where we take our step 2. We find the least common denominator between our two denominators. We're going to find our least common denominator. And then we are going to simplify with equivalent fractions. So an easy way to do this, usually you can just multiply these together. 3 times 10 would be a nice way to do that. I'm going to just break it down with the factor trees here, give us the whole step. 3 and 1 here, and we got 5 and 2 there. They don't have anything in common, but our 3 is going to be written out as 3. Our 5 is going to be written out as 5, 2. Take these individually. Type one of each. That is going to be 6 times 5 equals 30. So 30 is going to be our least common denominator. Just as I said before, we could have just done 3 times 10 and gotten 30 as our denominator too. So we're going to set these all equal so that 30 is the denominator for both. Okay, and now our last step is to figure out how we get from here to here. This is something we've been working on lately. How do we get from here to here? Well, I know to get from 3 to 30, we times 10. So we're going to times by 10 on bottom and on top. So that'll become 10 on top. 1 times 10 is 10. How do we get from 10 to 30? Multiply by 3. Multiply by 3 there and there. And there you have it. N equals 10 over 30 minus 9 over 30. We can do that one straight across. And we're going to be left behind with 1/30. N equals 1/30. Perfect. We got the variable by itself. We found that least common denominator. We simplified with equivalent fractions. Just like that. Stuff you already know how to do. We're putting it all together. We're piecing together the puzzle. All right, next one here. We're going to get y by itself. In order to do that, subtract this from each side. Those will cancel out, leaving us with y equals 5/9 minus 8/5. Look at that. We already have a common denominator. We don't even need to make another common denominator here. We just got to subtract. Subtract straight across. 5 minus 8 is going to be -3/9. From here, we simplify. I can see easily, I don't have to make my factor trees for this one, that they both can be divided by 3. To get y equals -1/3. Got that variable alone. They already had us with the least common denominator here. Simplified with equivalent fractions. Done deal. On to the next. We had to get n by itself. So in order to do that, we're going to add 3/4 to each side. N equals -5/8 plus 3/4. Right here, I see a really easy way to make these equivalent fractions. I'm just going to make this times 2 to get it up to an 8. So we're going to multiply that by 2, multiply that by 2, and I'll get n equals -5/8 plus 6/8. We're using those equivalent fractions. Those are going to come in handy a lot these next few days. Now we can just subtract straight across. -5 plus 6 is going to be a +1. N equals 1/8. Got the variable by itself. made those fractions equivalent, solve from there. All right, one more here. We have to get x by itself, get the variable all alone. So I'm going to add 2/7 to each side. We already have a common denominator, so we're going to do 6/7 plus 2/7 equals x. Add those straight across, and we get 8/7 equals x. Done right there. Those big steps. Get the variable alone. Find the least common denominator. It doesn't always need to be this. Sometimes it can just be a common denominator. But at the end, you'll have to simplify if that's the case. Just like we did on this one. We got it to -3/9 and simplified later. That's fine too. As long as you're simplifying that fraction with those equivalents, works for me. Oh no, mixed numbers. Don't fret. It's the same thing. We just need to make equivalent fractions, just like we did on the last slide. Or we can do decimals if we want. So I'm going to do 2 examples, and for each example, I'm going to do both ways using equivalent fractions and also using decimals. We talked about using decimals last week. So my first step is the same as on the other side, get that variable by itself. So we have p over here minus 1 3/8. So I'm going to add 1 3/8 to each side. And we get p equals 2 1/4 plus 1 3/8. Now, a lot of times I would tell you right now to make these into improper fractions, which we could do, but we don't need to. All we need to do is we need to figure out how to make these something that we can compare. Because I can do 2 plus 1 in my head. I just can't add these fractions in my head. So I'm thinking, how do I get from 4 to 8? I'm going to multiply this by 2, multiply that by 2. Whatever we do on bottom, we have to do on top. And this is going to become 2 and 2/8 plus 1 3/8. You can probably do the rest from here. I got this 1 plus 2 is going to be 3. And then we're going to do 2/8 plus 3/8. Add straight across the top is going to be 5/8. If you would like to, you could make those into improper fractions. And this could actually become a, let's see here, 8 over 8. It would be 18 over 8 plus 11 over 8. Add those straight across, and you would get 29 over 8. 8 goes into 29. 3 times, that's 24. That leaves it behind 5/8 extra. Use whatever strategy works best for you. I'm not going to limit you to one thing. Math has a lot of different options, a lot of possibilities. Use what works best for you. And that's why we're going to do this one with decimals. So our first step, again, is to get that variable by itself, same as before. Personally, using decimals is not my favorite approach on this just because it takes a little bit more time. But it can be a little bit easier to visualize. So what I'm going to do is I'm going to write this and this as a decimal. So I already know it's going to be a 2 in front and a 1 in front. So all I have to do is I have to figure out the second part of it. Remember, our top number goes on the inside. Our bottom number goes on the outside. I'm going to set this up for both. And we're going to put some zeros behind it. 4 goes into 1 0 times. Goes into 10 twice. Twice as 8. Subtract that out. Leaves behind 20. 0.25. You probably already knew that based on the 1/4. So we have p equals 2.25. Let's do this side. 8 goes into 3, 0 times. Goes into 30, 3 times as 24. Subtract that out. We get 60. Pull down to 0. We got 60. 8 goes into 60. Let's see. 5 times. Oh, excuse me. That is bad math. 7 times as 56. Subtract that, pull down to 40, and it goes in 5 times, and we get 0.375. Tag the 1 along with it. And we have a decimal problem right here. We're adding our decimals from here. Throw that 0 on the bottom while we're adding these up. This is something we did a while back. Quick little refresher for you. We get 5, 2, carry the 1, 6, And our final answer would be 3/625 thousandths. So you can do that using decimals, a technique we learned last week. Set those up with those decimals, solve from there. These are actually the same answer. All right, I got one more for you, and then I'll send you on your way. I'm going to do this first one with equivalent fractions. So my first step, this is a z. Put that over there, make it z. Get the variable by itself, so we're going to subtract from each side. Subtract 1 1/3. So now we have 3 7/18 minus 1 1/3. I need to make some equivalent fractions here, so I'm thinking, how can I get from 3 to 18? This one's going to work easily for me. Multiply by 6 on top and bottom. 3 7/18 minus 1 6/18. Start with my fractions. 7/18 minus 6/18 is going to leave behind 1/18. 3 minus 1 is going to be 2. And that is going to equal z. You could also use that, do the same thing with setting those into improper fractions. It's going to be a little bit of a bigger number, but you could do that as well. And using a decimal, we got to do the same first step here. Subtract that to get those by itself. And we get to 3 7/18 minus 1 1/3 equals z. Okay, let's set these up. I know that inside number, or top number goes on the inside, other number goes on the outside. Throw in my zeros. This is an 18 on the outside. That's kind of why I don't especially like to do this right now, because this is going to take a little bit of thinking. I'm going to use my calculator for the sake of time here. 18 goes into 70 3 times. So I got a decimal already as 54. That's going to leave behind 16. Carry on to 0. We get 160. It's going to go in 8 times as 144. Track that out. Going to leave behind, again, 16. Carry down to 0. And we're going to have a repeating process here. Leaving behind 16. So we got 0.38 repeating. So we got 3.38 repeating minus, and this side we're going to do 1/3. 1's going to be on the inside. 3 is going to be on the outside. Throw those zeros in there. Goes into 10 3 times as 9 minus 1. Goes into 10 3 times as 9 minus 1. Goes in, and you're going to see a process here, 0.3 repeating, so it's going to be minus repeating. And now this is why it might be a little bit easier if you see to use the equivalent fractions. We are subtracting some repeating numbers. It is doable, but it's not easy. And that will be equal to z. 0.38 repeating minus 0.3 repeating. Not the easiest thing to do in the world. We'll get left behind with, I could set this up like this, 0.38. We just have to know that this last number is going to be repeating. I can draw it out a few so you can kind of get the gist of it. And we'll get something that's going to be like 55550. So we're going to get 0.05 repeating for our decimals, and 3 minus 1 is going to be 2. So we got 2.05 repeating. And if I look here on my calculator, I can check this out. I got 0.5 repeating in here. I know this is a lot, but if I convert that to a fraction, I convert that the other way. 1/18 is going to be the same as 0.5 repeating. These are going to be the same answer. On this situation, I like the fractions more because it gives me an easier answer, easier subtraction, but the decimal is still doable. If that last one confused you, don't worry about it too much. That's a tough one, tougher than anything you'll see on a test and quiz. This is solving equations by adding and subtracting fractions. Use those 3 steps to success, and this should be a breeze for you. Good luck.